Today we're going to look at finding the mean of data. So if we have a set of data, we can calculate the mean and it can tell us more information about the data. So let's look at what that actually means. The mean is the sum, and we know that word from our expressions. That's the sum, adding up the values in the data set and then dividing it by how many pieces of data are collected. The mean tells you where the center of the data is. So it is also known as finding the average. So the average middle piece of the data. So if we look at this example here about a pearl diver and recording the sizes of pearls in a batch and finding out the mean of the pearl sizes, so it was the average pearl size that was discovered, we can often look at our data in a different way, such as a graph. In this case, it's a line plot. So you can see the different pearls are plotted on the line based on their size. So if we zoom in here to this example, we can see that all of the pieces of data, which is the size of the pearls, was added together and got 80. And that was finding the sum. After finding the sum, took that 80 and then divided it by 12. Now, why did the 80 get divided by 12? Remember that we're dividing by how many pieces of data there is in the entire data. So in this case, if we count each plot, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, there's 12 pieces of data. So they divided by 12. When divided by 12, you can see that it goes in 6 times, and there's a remainder of 8. So we can still put this in a value of 6 and 8/12. And because they're talking about the size being millimeters, it's 6 and 8/12 millimeters. So let's formulate some steps that were taken that we can always use if we're finding the mean of any kind of data. So the first thing we could say is we did what? We will always have to add all data. Okay. Obviously, a little bit more of a step to do challenge-wise if there's more data and if the numbers are a little bit larger than what we're working with and seeing here. The second thing we always do after we've added them up, we're going to divide the sum by the amount of data, the number of pieces of data, how many data points. You could say this in many different ways. So I'm going to try and say it the shortest, since these are supposed to be quick, easy steps for us to remember for finding the mean. I always joke that finding the mean is well named because it's more of the lengthy process than any of the other aspects when we're analyzing data. All right, so add all data, divide the sum by the number of data. What if we say collected too? Number of pieces of data. Okay, so also remembering that's where my sum came from. Then that's it. That's our mean. So every single pieces of data that we are analyzing, we can find the mean of just by adding them up and then dividing it by how many pieces of data there are. Staying organized with your data is going to be important so that you can make sure, one, you've added them all up and have all of them that you did collect. So let's look at this first example here. There are several bone fragments on display at the Science Museum. The line plot shows the lengths to the nearest 10th centimeter. Okay, so we see them all on the line plot here. So every single one of these is a bone fragment. So that's answering our first question, what does each X represent on the line plot? And that would be a bone, or we could even say a bone fragment. What does each number on the line plot represent? Well, that would be the size of the bone, since they are in that 10th of a centimeter there. How many pieces of data are shown on the line plot? Okay, so we can just count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I see 20 pieces of data. All right, now what? Oh, finding the average. So if we're finding the average, we're actually finding the mean. So we're going to go back up to our steps and we're going to add them all up, and then we'll divide by how many there are. We've even counted how many there are. So looking at each one of these x's, it's on the number line or line plot, we're going to use that number that it's located on. So we could do this in a couple different ways. Adding them up, especially when there's a lot, you can tackle this in your own way. So in our example, it was just one big long list. You could chunk them, whatever has more accuracy for you. I'm going to chunk them based on how many are here, because I can just do also multiplication. So I have a 0.4 times 2. I have a 0.5, that 5/10. I have that 3 times. And then I have 0.6. I have that 1, 2, 3, 4, 5. So you could line these all up and just add them, but I'm going to try and do smaller chunks. 1, 2, 3. So I have 0.9 3 times. And then I have one whole, 1, 2, 3, 4, 5, 6, 7. I'm just going to show you that, even though we know we can do that mentally. And really all of these are mentally. It's just a matter of where does the decimal go. So for 0.4 times 2, that is going to be an 8, but it would be a 0.8. And then 15, but that's going to be a 1.5. A 0.6 times 5, that's going to be 30, but a decimal right there. And 9 times 3 is 27, but our estimate, sometimes visualizing it helps, it's about 4, so our decimal definitely is going to go right there. And then 1 times 7 is 7. Now I'm going to add these all up, so I didn't have a really long list just to add all these individual pieces. So 0.8, 1.5, don't forget, adding decimals, we need to line them up by their place value. And then 7 has a decimal right there. Sometimes we forget that. And then when we add 8, 5, and 7 up, that would equal 20. Because 8 plus 7 is 15, and 15 plus 5 is 20. So now when I add these up, we have 7, 8, 9, I'm 10, 11, 12, 13, 14, 15. I see a 15. So our sum is 15, but we still need to do what with our sum? 15 needs to be divided by how many pieces of data there are. Oh, well, don't jump straight into this, because if I write this down and I divide it by how many pieces of data I have, that could be confusing. Remember fractions as division. So if we have 15 divided by 20, same thing as this, but that's our answer. 15/20. The average size is 15/20 of a centimeter. So looking at the data, we added them up, we divided by how many pieces there were, and we found the average size of these bone fragments. Let's try to find the mean of this data. So let's look at example 2. Tom kept track of how many pins were knocked over during their time bowling. What was the average amount of pins knocked over? So we can see the data in a different way here. We have tallies and showing the number of pins hit and how many times they hit that amount of pins. So when we look at this data and we're going to find the mean, because we're finding the average, we're going to take and add up how many there are here. I'm going to do what I kind of did with the line plots, and I can add them up within those tallies instead of listing 10 plus 10 and plus 8 plus 6 plus 5 plus 5 plus 3 plus 2 plus 1 plus 1. I can kind of add them up as I go. Now, I definitely want you to, as an example, see this happening. So, and a lot of you are probably like, I can add that up mentally. Yeah, definitely you can. So I'm going to still show my work and show my sum so you know where I got it from. So there's my 8. See, I got my 20 from my 2 10s. And then I have my 6. My 2 5s is going to be a 10. And my 3. And then a 2. And then 2 1s is also a 2. So adding these up to find my sum, I'm going to have 4, 5, 6, 7, 13. And then 13 plus 8 is 21. So then 2, 4, 5, 51 is my total for my sum. Now I have to divide that, but what do I divide it by again? I have to divide it by how many pieces of data. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 pieces of data. So again, don't just jump straight to dividing. Think about fractions as division as well, and that will help you do some more mental math. So this is the same thing. You could still do this. I'll walk you through it. So 50 goes in 5 times because 10 times 5 is 50. You'd have 1 left over. Do not put a remainder in here. If we want an average, I want the answer should be in an actual value. And the remainder doesn't always just tell us if we put the R. So if we look at this as a fraction, like I was talking about, we have 5 and 1/10. And that would, obviously you wouldn't have a fraction of a pin knocked over in a game of bowling, but it tells you you're a little bit over 5, but not quite 6. So you're more in that middle range of which one you're closer to. Now, sometimes an average might ask you of like how many whole pins or round to the nearest whole. In this case, it doesn't. So we are going to go put the exact answer. And our last example is talking about Sheila. She scored a 90%, 92%, 85, and a 93% on 4 tests. Now, if we want to find the mean of the score, what are we going to do? Add them up. So I'm going to list them here. Again, you could chunk them and do a couple at a time and then add those up. I'm going to list mine here. There's only 4 of them, so it's not that bad to add up. So if I add them up, I have a total of 360. Now, 360 needs to be divided by 4. This one's a little bit larger of a division. So I know that this can go in, well, not 100. And 9 times 4 is what? 36? Well, there you go. So 90 would work because that would get us an exact answer. So the mean, the average score, we're getting all these, on average, Sheila would get a 90% on her test. Now, this is where we can start pushing our thinking with mean, mean, and mode. In this case, with mean, we can manipulate the numbers to kind of think about different scenarios that could happen or that are potentially going to happen. So after the 5th test, Sheila has a mean of 91. So let's think about that. It's the 5th one. We did 4 tests, but her mean equaled 91%, right? So we had the sum, we divided it by, there was the sum, we don't know that yet, we divided it by 5 because we know that's how many pieces of data there were, and it ended up equaling 91%. So what could we do to figure out what would the actual 5th test score be? So that's not even the sum. That's the 360 plus we don't know what, right? So if we think about the inverse operation of what's happening here, we could multiply, right, 91 times 5 to figure out what this total would be, that sum. So 5, and that would be 45, so 455. Okay, so if the sum, including that 5th one, was 455, we don't want to know how much all of the tests together were, but we want to know what would that be for just the one. So I'm going to take away what the 4 would be, and what would be left is that 5th test. So if I do that here in borrow, I'm going to have a 95. So that 95 was added to the 360, divided by 5, and got a 91. So kind of manipulating which way you approach this, and it's not actually asking for the mean. So we have to be careful of that. It's the score, the fifth test score, so that 95%. But the main thing to remember is to find the mean, we add them up, we divide by how many pieces of data are, and no matter which story problem gets thrown at our way, we can always find the average or the mean of data.